On here it says phase changes are blank because I didn't get that one.
Physical changes. They're physical changes. Okay, we've been talking about physical properties, right? And physical properties are what we use to describe matter. What would we say is a definition for matter? What's the definition for matter? You got to know this for your quiz coming up next week. Caleb? Okay, it has to have two things. Good. Anything that has mass and takes up space, which means it has volume. Okay? To describe these pieces of matter, we talk about their physical properties. What is a physical property? Trinity? As an example of one, but give me like a definition. It does describe the matter. It's something that you have to be able to or observe. Good. Anything that you can observe or describe by the object. An example would be texture, like she said. What's another example? Bella? Weight. Parker? The state of the matter. Hannah? Pardon? Odor. Very good. Nathan? Size. Reagan? Shape, etc. On and on and on and on. What if I told you we were trying to describe physical properties of this matter? Ethan H?
It might be cold.
It might be cold. Okay, temperature-wise, it's certainly not hot, that's for sure. Bella? It has a blue color. Okay, Patty? It's pointy. Hannah? Shiny. Parker? It can be used to cut things. Caleb? It's sharp. Ethan, oh, okay. Davin?
It's made of plastic and metal.
Made of plastic and metal. What about the state of the matter? Connor?
Oh, I think it's different. It could stab you and hurt.
I don't think that's a physical property, but pointy and sharp are more like it. Reagan?
Two things. One, the state of matter is solid, and two, if you get close enough, you can smell a metallic fluid.
Okay, good. If we were to measure it, we could figure out its mass and weight and things like that. Okay, very good. So we've already discussed in detail the states of matter. Yesterday we also talked about the mass of the matter. Okay, what is mass? Look at your notes. What's our definition of mass? Jasmine?
The measure of the amount of matter an object contains.
Very good. When we're measuring the mass, we're seeing how much matter is in the object. Okay? What do we use to measure mass? I gave you two types yesterday, two examples. Landon? Good. A regular balance or a triple beam balance. Okay? Which one's more scientifically correct? Or what we use mostly in science? Parker? Triple beam balance. Okay? Which is what we're going to practice with later today as well. Now, beyond mass, we're also going to talk about two more today. Those are ductility and malleability. Okay? This is where your notes pick up for today. Ductility. D-U-C-T-I-L-I-T-Y. Ductility. Okay? Now, the easiest way to think of ductility is to think of duct tape. Okay? Ductility, duct tape. If you don't know, duct tape is not spelled D-U-C-K like the animal. It's D-U-C-T. Like this. Okay? Duct tape. So, ductility is a certain physical property of matter where usually it's used to describe metals. We don't typically use this property to describe any other object besides metals. But the easiest way to think about it is like duct tape. Okay? When you're using duct tape, you take it right off the roll and you stretch it out to get a piece of tape off, correct? Okay? The same thing is true with ductility. Ductility refers to whether or not you can take the metal and stretch it out into a thinner wire, basically. If you look at this picture here, you can see this screw. This is where the grooves are, correct? Like a screw that you would screw into something. It looks like someone put a clamp on both ends of the screw and applied what's called tensile pressure. They stretched it apart, okay? The metal actually did pull a little bit. You can see it gets skinnier, right? You see that? Okay, here's the other side. It gets skinnier, but here it got too skinny and it broke off. Does that make sense? Okay, that's a ductile metal. Now, some metals are more ductile than others. Okay, metals such as gold, silver, copper, erbium, terbium, samarium, those are very ductile. Okay, you can grab them and stretch them out into thin wires, which is typically why we use those kinds of metals to make electrical wiring. If you take electrical wiring and cut the plastic off, you see a bunch of copper wires usually. Okay, that's because copper is a very ductile metal. All right. There are some other metals, however, like aluminum, for example, that is not very ductile. If you take aluminum foil and try and stretch it out, it's not going to stretch, it's going to rip. Okay? That is not ductile. Does that make sense? Question.
So could you describe like fiber as ductile? Because you can make a rope out of it.
Can you take it and stretch it?
Kind of.
If you can take it and stretch it, then it has some bit of ductility. Yes. Landon? Is steel ductile? I don't actually know. Good question. No idea. All right, ductility. Next one is malleability. Okay, say malleability. Okay, your cue for malleability is the word molded. Both are M words. Not molded like moldy bread. Molded as in like shaped or pressed into a certain shape. Okay, malleability is the ability again of a metal to be pressed or pounded into a thin sheet. Okay? Again, this is only used to describe metals, not non-metals. Okay? A good example of malleability is Play-Doh. Okay, like what I have in my hand here. Play-Doh is a very malleable substance. Now, it's not a metal, so technically we wouldn't use it to describe this, but it does show you what malleability means. There are some metals that act like Play-Doh in that when you squish them, they can be molded into different shapes. There are some metals that if you squish them, they're not going to change shape at all. Okay? Pure gold, for example, is a very malleable metal. It's very easy to bend or shape. Okay? That's why back in the day when they first created the Olympic Games, raise your hand if you know what the Olympic Games are. Good. You know how the athletes go for first, second, or third place? First place is the gold medal, second place is the silver medal, third place is the bronze. Okay. Back in the day, one of the popular things to do was when they would get a gold medal, they would put it in their teeth and try to bite it. Okay? The reason why is pure metal, if you bite it, you could actually indent teeth marks into it because it's very malleable and soft. Okay? If it's not pure metal, or if it's not pure gold, they would bite it and it would not show their teeth marks. Okay? That would prove that it was not pure gold. Does that make sense? Okay? So that's why now sometimes you can still see Olympic athletes when they get the gold medal. Now it's just a popular thing. They'll take a picture like biting it, like putting it in their mouth, because of that. Okay, but that's malleability. Another good example of this is a blacksmith. Raise your hand if you've seen Mandalorian. Okay, you know how in that there's the episode where he gives her the Beskar metal and she like melts it down and molds it into the certain shape of its armor or whatever. That is an example of malleable material. Okay? The more you heat up metal, the more malleable it gets. Okay, that's exactly what a blacksmith does. Yes.
So like, there's this like thing you can get where it's like, it comes with like an action figure, but it also comes with this like treasure.
Okay.
And there's a chance it can be like plastic, but it's like dipped in real gold. And I got it once, and I tried to bite it, but it wouldn't like have the teeth marks because it's not pure gold.
Right, because the inside was
It
plastic.
still has gold.
Yep, that'll do it. All right, so what's the difference? This is not in your notes, just listen. Ductility is when a solid material will stretch under tensile stress. That's when you pull it apart. If ductile, a material may be stretched into a wire. Malleability, a similar property, is not being stretched out into a wire, but it's the material's ability to deform under compressive pressure. Compressive pressure. Okay? That's when you squish it. If it will deform when you squish it, it's very malleable. Okay? If malleable, a material may be flattened by hammering or rolling. Okay? I'm going to show you a video here now that gives you a good example of both kinds, both ductile and malleable. Right? Then we'll get into the